Hey guys, so this is going to be the last final portion of the ant scenario, but it's a big one. We've got three different pieces to kind of put together and do in order to make it so that the ants actually end up following the pheromone. So what we have up to this point, or what we should have, is we should have a scenario where we've got ants that crawl out of the hills and they just walk around randomly. They have no rhyme or reason of how they walk, but if they happen to find food, let's hope one of them does soon. There we go. Drops off pheromone on the way home, takes it home, and it adds one of these labels. So if you don't have ants that drop off food and continuously drop off and bring back food and add a label, you need to fix your scenario. Okay, either talk with myself or maybe watch a video and see if you can get it dropping off food. Okay, so it actually has to drop off food and add this label right here. What we're going to do next is we're going to make it so that the ants actually follow a pheromone. So say there's a pheromone here and there's an ant here. If it sees the pheromone, it's going to know it needs to walk to the center and then walk away from home, which means it's the pheromone means that an ant was coming from the food and dropping off pheromone. So the other ants know to follow the food away or follow the pheromones away from the particular home pile because that's the opposite direction of where the other ants came from. So it says here, if we noted that we recently found or we were recently at the center of a drop of pheromone. Now we can't really start this at this particular point. We actually have to start it on this piece that says else if we smell the pheromone now, because we haven't even dealt with the fact that it smells pheromone. So we kind of have to start building this algorithm halfway through the if, and else statement. So we're going to break this down by looking at specifically step 1. Now, before we get started with this, I want you to look at your scenario and I want you to look at your ant class. In your ant class, it should be basically built just like the algorithm that was closer to the beginning of the scenario that said, if we're carrying food, we need to walk towards home and look for it. Be like, hey, am I home yet? Am I home yet? Am I home yet? Am I home yet? Okay. And then we need to say otherwise. If we're not carrying food, we need to search for food. That way, the only thing that we have to change right now is us searching for food. Okay, so all we're going to have to modify is this search for food method. So let's head on down there. Okay. Now in search for food, all we should have so far is that we walk randomly around. Okay, because right now there is no algorithm in place. We also check to see if we've run into a food pile, and if we actually have, then we take food, we set the image to ant with food, and then we carry food. Okay, we record that we're carrying food. So what we're going to do now is we're going to optimize this search for food. In order to do that, we're going to start off just by checking to see if the ant has found pheromone. Now, we're going to do that above random walk because it should look like this. If the ant is searching for, or if we found a pheromone. Okay. Then do this. Okay, we haven't said what this is yet, but we'll say it in a bit. Otherwise, or else in computer science language, we're going to just walk around randomly. So our goal at first is not to make it follow the pheromones and do everything perfectly at once, but it is to get the ants to a point where they are searching for pheromones. If they find one, they head straight to the center of it. Now, in order to go straight to the center of it, we need to get information about it. Therefore, we can't just use is touching here. A lot of students ask, when can I use is touching? When do I have to use get one intersecting object? And the answer is that if you need to get information from a particular object, in the case of our pheromone, we need to find out what its location is. Then we need to actually get a pointer and use get one intersecting object. So we're going to start off by saying pheromone pH equals, cast it to be a pheromone, get one intersecting object. And we'll say we want to run into pheromone dot class. Okay. So then we need to say, if we found a pheromone, go to the center of it. So we're going to say if pH isn't equal to null, that means there's something inside. Okay, so if we found a pheromone, do this. So what's this? Okay, if we look at the algorithm here, if we smell pheromone now, walk towards the center of the pheromone drop. So let's do that part. Okay, so how do we do that? How do we know what the center is? Okay, I do give a hint on the slide saying if the ant and pheromone locations are the same, it means that the ant is at the center of the pheromone. Now, we have to actually get there first though. So let's look into the ant class. Okay, we have to actually move towards the center, okay, before we can even check. So let's look what is available in the creature class that would allow us maybe to go to the center. Okay, and if we, oops, sorry, scrolling a little too far. My computer's a little slow right now when I'm recording things. Okay, so here we are, we've got random walk, head towards, oh, head towards, that's probably what we want to do, right? We want to head towards the center of Greenfoot actor target. Now, what's our target? Our target is the pheromone itself. Do we have a reference pointer to pheromone? Why, yes, we do. We just checked if we were intersecting with the pheromone, and it returned back to us something into pH if we did. So we are going to head towards pH. Okay, but we also have to walk towards it, because if we look at what it says in the creature class about head towards, it says adjust the walking direction to head towards the given actor. So it's just the direction. It's not actually making it go straight there. What we want to do is walk forward in the current direction with the current speed. So let's go here. We're just going to type in walk. Okay. So now we want to say, have we found out the center of the pheromone? Okay. So it says, if we are at the center of a pheromone drop, start the walk away countdown. So we'll go back to the ant class here. Now to check if we are at the center, okay, check if we are at the center by seeing if the X and Y location of the ant and the pheromone are the same. Okay, to do that, we're going to simply make another if statement. We're going to say if this X's value, so if this ant's X value is equal to the X value of the pheromone class. A lot of people ask, well, how do I figure this out? Well, think dot notation. We have reference to the pheromone class. If you can use methods inside something from the pheromone class when we use get one intersecting object, can't we use the actor methods that are provided to it? I want you to take a second, maybe pause the video, see if you can figure that out. And if you can't, here it is. P dot get x. So if the x value of the ant and the x value of the pheromone, pH dot get x, because we called it pH, and get y is equal to pH dot get y, okay, if that's all good, then we've hit the center. And we want to basically start our countdown, okay? So what we're going to do is let's have something that actually initializes or kicks off this countdown, okay? We're going to go and we're going to create some variables here. Let's create one called private, and we'll make it a Boolean just to keep track of this. You don't have to do this. You could actually just do it with an integer, but this might make a little bit more sense for you guys. So private Boolean hit center recently. Okay, so if we've hit the center recently, okay, then it's going to go to true. So we're going to start it off as false. You should always start off by declaring a bunch of variables. You're declaring your variables first, okay? So definitely declare it and initialize it to be something. Okay, so we definitely want to initialize something, or initialize it to be something. So it's going to start off as false. And what we're going to do from here is we're going to say, if we've hit the center, okay, we'll say hit hit center recently. We'll set it to true. Okay, so I'm going to compile this. Oh, looks like something's wrong. Maybe I spelled that wrong. What did I do? Okay, let's see. What does it not like? It says there's an error found in my class. I'm missing some brackets here. So, like I said, if we found a pheromone, do this. Otherwise, walk around randomly. We just need to add another curly bracket here. And let's see, will it compile? It looks like it did compile. My computer's running extra slow because I got too much running. I'll fix that in a little bit. Let's see. This should compile at some point. Here we go. Okay, so our goal is to have the ants come out of the food hill, or out of the anthill, move around randomly, hit the food, bring pheromones back, and the other ants should actually get attracted and walk towards the middle of it if they find the pheromone. So let's add some ants. We'll run this. They'll wander around. Okay, here we go. Okay, so let's check. Here's a pheromone. Let's see. When this ant touches the edge of the pheromone, what happens to it? Oh, it went to the center until it faded away. Did you see that? Just to illustrate again, I can even just use a pheromone here, drop it down. Oh, let's get this running first. Let's get a couple ants out of the anthill. Okay, pause it again. I'm going to drop off pheromone. Okay, and again, watch. It should, if it's touching the edge, it should go straight to the middle, and then once the pheromone fades out, it's going to walk away. Okay, but it should actually go and walk to the center, stay there until the pheromone fades out. There we go. That worked. So we're going to go on to the next part in the next video. So make sure your scenario is working up to this point, that your ants are picking up food, dropping off pheromone on the way back, and heading towards the center of the pheromone.